Hello, Assalamualaikum, salam sejahtera and good morning students of 4 Arcade, 4 Baiduri and 4 Citrin. So welcome back to our physics class after 1 week holiday. So is it enough 1 week holiday for you? I want to join studio. Okay, Ong Cheng, later I'll send the invitation link. So for those who would like to join me in this studio, you can click on the Conti link. I share with you later on. Okay, so class, I hope you are ready to begin with the lesson. So for today's lesson, I've streamlined it on YouTube. So those who, because some of your friends PM me just now, cannot follow this lesson for some private reason. Okay, so I hope you can refer back to this video later on. But before that, for your information, I have attached an exercises sheet for today's lesson in your Telegram group. So I hope you have go through them, and if you have a printer back home, you can print them out as well. Okay, so before we begin with our lesson, so this is the exercises I shared to you earlier, so you can check on them. This is all exercises on specific heat capacity. Okay. Alright, so most of the questions are from the SPM past year question, which is a very good exposure to each of you to familiar yourself with the SPM format questions. Okay, so I hope you can get them from the Telegram group. Okay, can you tell me before for specific heat capacity, where do we stop last time? Because I'm not very sure where should I continue from. So this is our previous module on specific heat capacity. Can you respond to me until which part we have discussed, students? Boleh check tak the previous module? Specific heat capacity saja. Ini sudah ke eksperimen 4.1 and 4.2? Are we done with this? How to determine specific heat capacity for water and aluminium. Ini sudah atau belum? Can you respond to me? Anyone? Can you check the previous module? So until where we have finished our discussion. Ini belum lagi. Okay, tak apa. So I think I continue from here. Sudah. Activity 3 done or not? Activity 3 to investigate specific heat capacity. Okay, this one done. What is the meaning of specific heat capacity of aluminium? Can you please check? Nicholas. Nicholas is in studio. Nicholas, can you check? Are we done with this? Ini sudah. Okay. Kenapa ada yang sudah, ada yang macam no? Okay, tak apalah, cikgu ulang semula. Okay, so if you remember, I have discussed with you what is heat capacity and what is the meaning of specific heat capacity. So if you remember, heat capacity refers to amount of heat required to raise the temperature of substance by 1 degree Celsius. Okay, while specific heat capacity refers to the amount of heat required to increase the temperature of 1 kilogram object by 1 degree Celsius. Okay. For example, they ask you this question. What is the meaning of specific heat capacity of aluminium? 900 joule per kilogram per degree Celsius. So it refers to 1 kilogram of aluminium needs 900 joule of heat to raise its temperature by 1 degree Celsius. You can click on the StreamYard link to join my studio. Okay. Number 2, what is the meaning of specific heat capacity of water? 4,200 joule per kilogram per degree Celsius. So it means that we need about 4,200 joule of heat, okay, to raise the temperature of 1 kilogram water by 1 degree Celsius. Okay, students. Okay, and ini belum lagi kan? Ini example of question how to determine either heat or either specific heat capacity or temperature change. Okay, for an object involving specific heat capacity. Okay, look at question 3. Again, for those who like to join me in my studio, you can click on the StreamYard link which I attach here. Okay. Okay, so this is question 3. Kalau you tengok di sini, we have a metal. Okay, it has, yeah, hello, welcome to my studio. Okay, a metal has a mass of 2 kg. Okay, we have to calculate the amount of heat that must be transferred to the metal to raise the temperature from 30 degree to 70 degrees Celsius. So this is the question you are given with. And also you are provided with the specific heat capacity of the metal, which is 500 joule per kilogram per degree Celsius. So students have to find how much heat is required, okay, to raise the temperature of the metal from 30 to 70 degrees Celsius. So you may check with your calculator. So what is the formula we apply here? Okay, those in the studio, you can respond to me, open your mic, or you can open your camera as well. Those below, you can respond in the live chat. Okay, please calculate this question. Find how much heat is needed. Okay, so what is the formula we apply here? Can you type the formula we are applying here for question 3? Okay, anyone? The formula is, okay, you type the formula at the comment section. Okay, those in the studio, you type the formula at the comment section. You type them at the private chat. Only we in the studio can see. Those out there cannot see them. So you type at the comment section. All right. So we are using Q equal MC delta theta. But before that, this is the information you are given with the mass 2 kg. This is the temperature change, which is 40 degrees Celsius. And the specific heat capacity is 500. Okay, so we apply Q equal MC delta theta. So you do the substitution. M is 2, C is 500, delta theta or temperature change is 40. So it will give us 40,000 joule. Okay, 40,000 joule. Okay, then how many joule? Okay, question 4 is a bit the same. Okay, it's a similar question. How many joule of energy means how much heat is required? Okay, we are total of 54 students who joined us now. So monitor, please call up your friend to join this lesson. Ada separuh lagi tak join. Okay, which is bad. How many joule of energy are required? Okay, to raise the temperature of 100 gram. Now we have 100 gram of gold. From initial temperature of 200, final temperature of 100. Okay, given the specific heat capacity of the gold is 129. Okay, so how to find? Again, you are given with this info. Remember students, mass is in grams, so you should convert them into kg, which is 0.1 kg. Okay, 0.1 kg. And this is the temperature change, which is 80 degree Celsius. And specific heat capacity of gold is 129. Okay, so nothing difficult, nothing is complex. Then you determine what is the formula we apply. Again, Q equal MC delta theta. So we are looking for this Q, amount of heat required. Okay, so the mass is 0.1, NC is 129, temperature change is 80. So it will give you, yes, 1032 joule. Okay, hi, your device is not connected. Okay, sudah ada 2 devices. Okay, you can share your answer in the comment section. Okay, students. So let's check what's next. Okay, So this experiment you can find in your textbook. It is an experiment to determine specific heat capacity of water. So class, theoretically, can you tell me what is the specific heat capacity for water? What is the specific heat capacity of water? What is the amount?
4,200.
Yes, very good. It is 4,200 joule per kilogram per degree Celsius. So we want to prove, is it really 4,200? So we can conduct an experiment in the laboratory with all these apparatus and material. Okay, so this is the setup of the apparatus needed in this experiment. You can see there is a beaker of water and there is an immersion heater placed inside the beaker. Okay, and you can see that the beaker is wrapped with tissue paper. Okay, and this is where the thermometer is placed on. So you can read the setup as well. First, we record the initial temperature before we switch on, okay, the power supply. So we record the initial temperature first and label it as delta theta 1. Okay, first we record the initial temperature as theta 1. Okay, then when you are ready, we switch on the power supply, and at the same time we we press the stopwatch. Okay, we start the stopwatch at the same time. And then after several time, after 5 minutes as written here, we switch off the immersion heater, and then you off your stopwatch and you record the final temperature as theta 2. Okay, so it's a very simple experiment. Okay, and this is the find out, okay, in this experiment. So this is all the information we have to record. What is the power of the immersion heater? Okay, what is the heating time? What is the mass of water? Initially, we have to measure. Okay, we have to measure the mass of water using a balance, inertial balance. Okay, and this is the initial temperature and final temperature we record from the previous experiment. So in order to determine the specific heat capacity, this is the formula we apply. C equal to PT. PT ini electrical energy supply by the heater. Power multiply time. Okay, heat energy supply. Okay, heat energy supply to the water is coming from the power, coming from the heater, immersion heater, where the formula is Q. Q ini for heat energy. Electrical energy is PT, power multiply time. Okay. Okay, then this is the question which may come out from this study. Okay, why does the beaker need to be wrapped with cloth? So why do you think the beaker need to be wrapped with cloth or with tissue paper? Anyone? You can see in the diagram just now, the beaker is wrapped with tissue paper, or sometimes we are using clothes in the laboratory. Why we have to wrap the beaker with this paper or cloth? Any idea?
To get more accuracy.
To get more accuracy. Okay, it's too general. Can you go more specific?
Reduce the thermal contact.
Reduce thermal contact. Okay, actually it is to prevent, okay, to reduce heat loss to the surrounding. So you will get a more accurate result, okay, to reduce heat loss to the surrounding. Okay, then second question, why the final temperature of water is not taken as soon as the 5-minute heating time ends? Why you have to spend a few times before you record the final reading after 5 minutes? Any reason? Anyone?
Thermal equilibrium.
Yes, very good. To make sure that thermal equilibrium between the water and heater is achieved. Okay, thermal equilibrium between the water and the thermometer actually, okay, is achieved. So number 3, given the standard value of specific heat capacity is 4,200. This is the theoretical value, 4,200. But in this experiment, normally the amount of C that we get is higher. Okay, is a bit higher from the actual or the theoretical value. And why is that? Okay, it is because there is a heat loss to the surrounding occur while we are conducting this experiment. Sebab itu dia selalunya lebih tinggi. The value of C we determine from experiment is normally higher compared to the actual or the theoretical value because there is a heat loss to surrounding occur during the experiment. Okay, and this one goes the same. Experiment to determine specific heat capacity of aluminium. Okay, who knows what is the specific heat capacity for aluminium? The theoretical value or the actual value? It is? Anyone knows specific heat capacity for aluminium?
900.
Yeah, it is 900. Okay, 900 joule per kilogram per degree Celsius. So this is the apparatus and material required for aluminium. Okay, so this is the setup of the experiment. So this is the aluminium block. Okay, as you can see in the figure. And again, it is wrapped with tissue paper, or we can use a clothes to wrap the aluminium block. And this is where we place the immersion heater to supply heat to the aluminium block. And this is where we insert the thermometer. There is a hole there, if I can zoom for you. Okay, there is a hole here where we place the thermometer in. So it will record the initial and final temperature of the aluminium block. Okay, and this is all the particular we have to collect, we have to record during this experiment. How much power is supplied from the heater, the heating time, mass of aluminium. Before that, we have to measure. Again, you kena timbang dulu berapa, and the initial temperature and the final temperature as well. And how to find C from this formula? Again, we can calculate C from PT divide M delta theta. Okay, what is PT? This is the electrical energy supply from the immersion heater. Okay, and again, this is the question which is normally asked related to this experiment. What can be done to obtain a better thermal contact between the bulb of the thermometer and the aluminium block, students? Okay, you can see in earlier in this diagram. So how to make sure the thermometer and the aluminium block has a better thermal contact? What can we put inside the hole before we inserting the thermometer? Any idea?
What means? Don't understand.
Okay, sekarang you tengok sana ada lubang kan? Okay, you can see, okay, I go back to the previous slide. Okay, you can see that, okay, there is a hole here. Okay, and when you place the thermometer is not 100% in contact with the aluminium block. There will be a spaces, ada ruang. So, how to ensure a more efficient thermal contact between the thermometer and the aluminium block? What can we place into the hole before we inserting the thermometer to make sure it is 100% contact between the thermometer and the aluminium block? So you boleh letak apa dalam lubang?
One conductor.
Huh?
One electric, heat conductor.
Heat conductor. Any other answer? Any other idea? So
Where
what can we?
Bulb, my teacher?
Sorry, come again.
Where is the bulb?
Where is the bulb? The bulb of the thermometer is at the end of the thermometer.
Oh, there's something like gray color.
Yep. Okay, where the mercury is inside. Okay.
Oh.
So actually, what can we do? We can put in. We can add some oil. Okay, normally we are using cooking oil into the hole of the aluminium block before inserting the thermometer. Okay, kita masukkan minyak ke dalam itu. Okay, so now it will create a better thermal contact between the thermometer and the aluminium block, as no more blank spaces, okay, between the thermometer and the aluminium block. Okay, and question now, yeah.
The thermal contact is switched to thermometer and oil.
Yeah, so the oil will in contact with the aluminium block, and then it will be in contact with the thermometer at the same time. So the oil is act like a bridge, okay, to
Why
link.
we use oil?
Ah,
Why we use oil?
because oil has a very low specific heat capacity, so it can detect changes, temperature changes very fast. Okay.
Okay.
Okay, it's a very good question. Okay, Sinwei, I hope I am answering your question why we add oil. So the oil is act like a bridge, okay, to give a better thermal contact between the thermometer and the aluminium block. And why we choose oil instead of water? Because oil has a very low specific heat capacity, so it can detect temperature changes in a very short time. Okay.
And also, why we use oil for frying something? Also
Yeah.
same theory.
Yeah. Same
Oh,
reason. Okay.
okay.
Okay. Then question number 2 is as the previous one on experiment on water. Normally in the laboratory, the value that we will get is higher than 900. Okay, higher than the theoretical value. This is again due to heat loss, which is occur during the experiment. Okay, there will be a heat loss to the surrounding. Okay. Okay,
Teacher,
then yes.
can we change the tissue paper to plastic? Plastic bag.
Is plastic an insulator? Actually, you can use any kind of insulator. It can be a polystyrene, it can be a cloth, it can be a newspaper. So it can be any type of insulator.
The
Okay?
condition is mass insulator.
As long as it is a heat insulator, so it is we can use, it is applicable. All right?
Okay.
Okay, now student, the next part, okay, application of specific heat capacity. Okay, this is very important for you to know where in our daily life we apply this concept of specific heat capacity. Okay, so first you can check on the selection of building material of traditional houses in various climate zone. So if you check on these two houses, they are both built from what? What is the main material in order to build these two houses?
Wood.
It is made from wood. Okay, you can see if you zoom out, this is the traditional houses in a warm climate region. Okay, and below there is a traditional houses in a cold climate, okay, region. Both are made from wood. So why they choose wood as the main material to build these traditional houses? Okay, so you can see that wood is a material which has a very high specific heat capacity. Okay, which means it get hot slowly. Okay, welcome James Brooke. Okay, whoever your actual name is. Okay, then so in warm water, in warm weather region, okay, dalam negara yang beriklim panas macam di Malaysia, in a warm weather regions, why the traditional houses are built from wood? So wood here is function as an insulator. Okay, insulator of heat from the scorching sun. So outside is very hot, especially during afternoon. So the wood will prevent the heat from entering the houses. So the temperature inside will be lower compared to the temperature outside. So it will prevent the owner of the houses from extreme heat. Okay, berbanding kalau rumah daripada konkrit. Kalau you perasan, okay, most of you are living in town where the houses is made from concrete. Okay, concrete is a material with low specific material. Sebab itu rumah kita panas. Okay, cepat panas. It get hot quickly. Okay, compared to houses which is built from wood. Okay, but now in cold weather region, kawasan yang beriklim sejuk, their traditional houses also built from wood. Okay, again, the wood here is acting as a good heat insulator. Okay, if you look at these houses in a cold places, so what normally the people inside do to warm themselves? Dia buat apa untuk panaskan diri? They will light up a fire inside, right? Okay, they will light up a fire inside to keep the person inside to be warm, okay, from the cold weather. So when they light the fire inside, okay, so the wood will prevent the heat from escaping out, okay, from the house. So it will keep their house warm. So you boleh tengok, okay, on top, the wood prevent the heat from entering the house. Okay, while in a cold weather region, the wood will prevent the heat from escaping out from the house. Okay, boleh tengok dengan jelas. Okay.
Teacher,
Yes.
If the question asks, no, if now the question is, there is one object which has a high specific heat capacity,
Okay.
but also have low burning point.
Low melting point.
No burning point, so it's easily to fire, easily to burn. Burning
Example?
Point. Like paper, enough of heat and it will burn ma.
Oh, okay.
I don't know.
Normally for an object with high specific heat capacity, for example, water, or you can give any object with high specific heat capacity. Normally they have a high melting point. Okay, when you burn a paper, that one is not considered as the melting point of the paper is low. Kertas memang senang terbakar, but you cannot say that paper has a low burning point. Okay, we didn't see it in that way. Okay, normally for an object with high specific heat capacity, the object also has a high melting point. Okay, this is how we pair them. Okay.
Oh, so for wood also have high burning point.
But in physics, we don't have this term as burning point. Kita tak guna terms ini, burning point. We only use a freezing point, melting point, and so on. Okay?
Oh, okay.
Okay. So you know the reason of using wood as the main material. It is act as a heat insulator. Okay, in warm weather to prevent heat from entering the house, and again in a cold weather region to prevent the heat from the fire to escape from the house. So it will keep the people inside to be warm and comfortable. Okay. Kita tengok yang kedua, cooking utensil, ya, peralatan memasak di dapur. If you go to your kitchen, okay, your mother's cooking utensil, you can see that normally the wok kuali ni, normally they are made of metal. Okay, metal with low specific heat capacity. Why is that so? You can think the logic. Okay, why the wok is normally made from a material with low specific heat capacity? Okay, this is to make sure that the food can be fried at a high temperature in a short time. So remember, a material with a low specific heat capacity, it absorbs heat very fast. So the temperature raise up very fast. So the food can be cooked faster in a short period of time. Okay. While if you see the clay pot there, clay pot ini made from clay. Okay, clay is a substance, is a material with a very high specific heat capacity. So normally we use clay pot if you want to keep the food to be hot, okay, to stay hot in a longer period. Okay. Contohlah mak kamu masak pagi, dia masak bubur. Tapi dia nak petang, the bubur, the porridge is still in a hot, okay, in a hot condition. So once cooked, you can cook in a metal pot, you can cook in a metal wok, but if you want to keep, you can keep it in a clay pot. So it will keep the porridge hot in a long period of time. Okay, itu reason why wok is made from low specific heat capacity and why clay pot is made from a material with high specific heat capacity. Okay, are you clear with me, students?
Yes, yes.
Oh,
Teacher,
yes.
can we make more efficiency if we are cooking? Let's say I shorten the time for cooking one diet.
Uh-huh.
Maybe for now I cook spaghetti, I need 30 minutes. Can I
Oh,
shorten the time?
okay. So
Shorten the
you
time
can
by
yeah, by
maybe using the same pot.
okay.
Yeah lah, using the same pot. And can I shorten the time? Maybe become 15 minutes or how like that.
Okay, actually there's a few way you can shorten the time. Number one, you supply more heat. Okay, number one, you supply more heat. So
Uh-huh.
it can cook it can be cooked faster. Or what else you can do? You can choose a wok with a more with a lower specific heat capacity. Okay, then you can cook them in a shorter time. So there's a few
Uh,
factor you can change.
if I greater the temperature gradient, can it more efficiency?
It will be cooked in a shorter time. Means the temperature changes is very fast. Okay,
So the greater the gradient, the shorter the
the
time.
shorter the time. Yes. Okay.
Can I calculate out the gradient, the thermal gradient
Uh-huh.
between two objects?
I didn't get your mean.
Um, okay. Later I ask in group maybe.
Okay, okay, you can PM me later on. Okay. Okay, then again with cooking utensil, okay, now you can see this pot. Normally the body of the pot is made from low specific heat capacity. So it can heat up quickly and the food can cook in a shorter time. But for the handle, normally for the handle of the pot, it is made from either from wooden handle or from polymer. Plastic is a type of polymer. Okay, in chemistry, you learn polymer. Okay, polymer is a material or wooden is a material with high specific heat capacity. So why the handle is made either from wooden or polymer, so it will get hot slowly. So it is safe for you to handle. Okay, it is safe for you to hold them during cooking. Okay, kalau handle itu made from metal juga, so dia panas. So you susah nak pegang and it can cause you an injury. Okay, Tan Yifong is in our studio. Welcome. Okay. Okay, next application. Okay, in a car radiator system. Okay, you can see that normally this question, it used to come in a SPM past year question before. Explain the cooling mechanism in a car radiator system, 4 mark. Okay. So students, for car radiator system, as you can see in this diagram, normally we use water as a coolant. Okay, we use water as a coolant liquid. So why we are choosing water as a coolant liquid? This is because water is a substance with a high boiling point. So it does not evaporate easily. Okay, it does not change into gas easily. Second, water is a material with a high specific heat capacity. So it can absorb a lot of heat from the car engine. And third, water is very cheap, abundant, mean we can find it everywhere. You senang nak dapat. air. Okay, it is abundant. Abundant mean we can find it everywhere. Senang nak jumpa. Okay, economical, cheaper, and save cost. Okay, now how the cooling mechanism. Okay, you can see that I label this diagram with number 4, 1, 2, 3, and 4. So how this radiator system works in order to cool down our car engine. Okay, so first a pump will pump the water into the engine block. So you can see there is a pump there to pump the water into the engine block. And then later what happened, number 2, the water will flow through the engine block and absorb the heat produced from the engine. And then third, what will happen? So once the water absorb heat, so it will get hot. Okay, so the hot water then flows to the radiator. Okay, point number 3, up there. And what happened inside the radiator? There is a fan there at the radiator. So this fan will suck in air from outside and to cool down the hot water. So the water will be cooled down and flow back to the pump, and the process begin again and again until when? Until you stop the car from moving. Okay, you stop the engine. So this is the cooling mechanism in car radiator system from number 1 to number 4. Okay.
Oh, teacher, they cool down the water by the airflow.
Yeah, the air, the cooling air, there's a cooling fan there at the radiator. So the cooling fan will absorb cool air from outside. Okay, so cool air get into the engine and it will cool down the hot air, release the heat from the water. So the water will cool down again and then send back to the pump. Okay,
Oh,
got it?
how the
Okay,
air become cold?
yeah. Air from outside. The air is start from outside of the car, from the surrounding. Okay, absorb into the heat. It will be sucked in from the cooling fan at the radiator. Sini ada fin. We have a fin and cooling fan. You can see the cooling fan there.
Oh, yes.
Okay, I zoom it for you. Okay, see the cooling fan here. So it absorb. Okay, it absorb air from the surrounding. So it will cool down the hot water. So it lower down the temperature of the water and will send back to the pump. And the process begin again and again. Okay?
Oh, okay, okay.
Okay, very good question. Okay, next application. You can see the next application on the outer layer of a space capsule. Okay, we send a space capsule to the outer space to do investigation or research, okay, on a specific field. So normally when this space capsule about to return to the Earth, so they will return with a very high velocity. So in doing that, they will generate a lot of heat due to the friction, air friction between the body and the air molecule. So there is a possibility there will be a risk for the space capsule to be burned, okay, in order to the journey back home. So we don't want this to be happen. We want to prevent the space capsule from burning. So what they do is the outer layer of the space capsule is made from a substance with a very high specific heat capacity plus a very high melting point. Okay, senang saja. Because sometimes in the space capsule there is an astronaut inside. Kadang-kadang dia ada astronaut di dalam tu. Okay, so we want to prevent any injury. So the outside layer must be built from a material of a very high specific heat capacity and very high melting point to prevent it from burning. Okay. And next, this is a new building construct in our country. You can see it is called as a diamond building, bangunan intan. Okay, you can see the structure is a shape like a diamond, and this is also a green building, bangunan hijau. Not because the color is green, but green building or green technology means it is environmental friendly. Okay, we design to reduce the carbon effect, the carbon footprint. Kita nak kurangkan, okay, to release the greenhouse effect. to reduce the greenhouse effect. So diamond building ini, if you look at the structure of the roof, okay, dia punya bumbung. Okay, the structure of the roof ini is made from laminated concrete. Okay, kau tengok dia concrete sheet, and then there is a cement layer there, and this is the styrofoam insulating board. Okay, and on top is a cement layer. So it is a multiple structure concrete building. Okay, so you can read here, insulator, the roof is an insulating concrete roof, okay, which is fitted with styrofoam board. You know what is a styrofoam, right? If you buy an electrical devices, normally it will cover with the styrofoam, the white thing itu, to prevent it from damage. Itu kita panggil styrofoam. It is an insulator with a very high specific heat capacity. So why we layer them with the styrofoam? So this is to reduce absorption of heat from the surrounding. So when you are inside this building, you can feel that the temperature inside this building is very low. Okay, like there is an air conditioner, tapi dia tak perlukan aircon pun sebab they use this system. So the temperature inside the building is much lower compared to the temperature of outside the building. Okay. So in the future, if any one of you become an architect, become an engineer, you can advance this technology so it can work to be more efficient. Boleh design lagi, boleh bagi dia lagi efficient. Okay, the technology is changing very fast nowadays. So every day we found a new invention from the previous one. Okay, this one I believe you are familiar with, sea breeze and land breeze. What is sea breeze, students? Can you give a short explanation? What do you understand by sea breeze? Apa itu sea breeze?
Sea breeze is the sea is cold than the land.
The sea is cold than the land. Okay, so generally we call sea breeze as the movement of air. Okay, sea breeze refer to the movement of air from the sea towards land. That's why kita panggil dia sea breeze, as the wind is coming from the sea. Okay, so how does sea breeze occur? Actually, this phenomenon is referred to specific heat capacity. So what happened during daytime? Sea breeze occur at daytime. So at daytime, you can see sea and land is a two different material. It's a material with a different specific heat capacity. Sea has a very high specific heat capacity compared to land. Okay, which is the sand. Sand is a material with a low specific heat capacity. So it says here, point number 1, land has a lower specific heat capacity compared to the sea. Okay, so therefore what happened, the temperature on the land rise up quickly because remember, an object, a substance with a low specific heat capacity, they absorb heat very fast. So the temperature rise up very fast. Okay, means at the daytime, the land become hot quickly compared to the sea. Darat lebih panas berbanding dengan laut. Okay, then number 3. So what happens? So the air above the land and the hot air above the land will rise upward. Okay, will rise upward. Sebab dia hot air dia less dense, dia akan rise upwards. So when the hot air rise upwards, it will leave. Dia akan tinggalkan a partial vacuum region di sini. Okay, dia akan tinggalkan a partial vacuum or a low pressure region. Okay, sini partial vacuum, or we say low pressure region. Okay, so what happened? The cold air above the sea, which is denser, will move to the land and fill up these empty spaces. Itu yang akan berlaku. So cold air from the sea move towards the land, which we call it as a sea breeze. So you can see the sequence from number 1 up to number 4. So students, when they ask you to explain sea breeze, normally it is a 4 marks essay. Okay, 4 marks essay. So mark number 1, mark number 2, mark number 3, mark number 4. Okay, ini boleh tambah sikit. Rise upwards, creates, ini letak comma, a low pressure region. Okay, and finally, the cold air from the sea will move towards the land. So that is sea breeze. Alright. Okay, and the last application to be discussed is land breeze. Okay, land breeze occur at night. What is land breeze? A movement of air from land towards sea. Okay, a movement of air from land towards the sea. Okay, so how to explain land breeze? Sama juga. Okay, sea has a higher specific heat capacity compared to land. So what happened? So sea ini dia release heat slowly compared to land. So the land release heat very fast. Remember, a material with a low specific heat capacity, they absorb heat very fast and they also release heat very fast. Okay, while an object or a substance with a high specific heat capacity, they absorb heat very slow and they release heat also very slow. Okay, so it will keep warm in a longer period. So pada waktu malam, laut ini dia lebih panas. Okay, because it release heat slowly compared to land. Therefore, temperature in the sea drops slowly compared to land. So hot air above the sea is less dense, so it will rise upwards. And again, will leave a partial vacuum region or a low pressure region. So what happened? The cold air from the land will blow towards the sea and we call it as a land breeze. Okay, sama juga if they have asked you to explain, it will be a 4-mark explanation. So each point secure you 1 mark. Okay, are you clear with this land breeze and sea breeze? Okay. Okay, so I hope you're okay with them. Okay, kita tengok sekarang. Okay, before we try to do a few questions to solve a few problem related to heat capacity, this is what you must know. Okay, in order to solve any problem involving heat, this is the conversion of energy which might have. Okay, the first one, if you are using an electrical appliances, for example, a heater, so you know that the energy conversion is electrical energy convert to heat energy. So in our calculation, we are using PT. Okay, PT equal MC delta theta. Okay, while second, when an object is fall from a certain height, let's say there is an object fall from a height of 15 meter. So what kind of energy changes occur? Potential energy convert into heat energy, okay, due to the resistance of A. So mgh equal mc theta. And then third, kinetic energy. Example, there is a moving object. Okay, there is a moving object and finally the object stop. Okay, so the conversion of energy here is kinetic energy convert into heat energy. So the formula we are using is half mv squared. If you remember, this is the formula for kinetic energy, equal mc theta. Okay, so ingat ini electrical energy, potential energy, kinetic energy. This is all the equation involve the conversions of energy. Okay?
Sure.
Yes.
We assume that there's no heat loss.
Yeah. Yeah, we assume in all calculation, we assume that there is no heat loss to the surrounding. Okay?
Okay, but for realistic situation, the heat loss will appear.
Yeah, in the real life there must be a heat loss somewhere. Mesti ada heat loss. because heat loss due to friction. Okay, it may heat loss due to sound and
Sound.
in other ways. Because bila objek jatuh, dia tukar kepada kinetic energy, convert into heat, convert into sound energy. Okay.
Oh,
So heat can be
Fikir
lost
tiga.
it can be lost in many ways. Okay.
conversation energy.
Yeah, conversion bukan conversation. Conversation itu talking. Conversion, convert. Convert.
Conversion.
Teacher, teacher.
Yes, convert. Yes.
Teacher, what if we consider heat loss is in our calculations?
Normally in our calculation, we always assume no heat loss. Mean 100% kinetic energy convert to heat. 100% potential energy convert to heat. 100% electrical energy convert to heat. Okay.
Or can I calculate out how many percent is convert to kinetic? How many percent is convert to sound? How many percent is convert to potential?
If you
And
go more
all
detail, actually you can count. But for our level, we don't go up to that extension. Kita tak pergi
Oh.
sampai sana. Okay, maybe when you be in form 6, you akan discover that how many percentage of loss in order when there is a conversion of energy occur. Okay, but for SPM level, in our calculation, we always assume that 100% of conversion.
1 to 1.
Yeah, 1 to 1. It is 1 to 1. Okay, so 100%
Okay.
efficient. All right.
Okay.
Okay, now let's check on this question, how to apply. Okay, what do we have here? You are given a kettle. Ini yang cikgu bagi kamu tadi, the exercise sheets. Okay, we have a kettle supply with a power of 1000 watt. So you have to calculate the quantity of heat generated in 5 minutes. So we want to count what is the heat generated by the heater, by the kettle in 5 minutes. Okay, so what is the formula we are using here? You nak kira apa? We want to count heat, Q. So Q here is given by electrical energy. So Q equal PT. So power is 1000 and the time is 5 minutes. Remember, the time must be converted to second. So 5 times 60. So the heat generated is 300,000 joule. Okay, clear with that? First question, very simple, very basic.
No, teacher.
Haha.
We know, even though we know we need like this amount of energy, but we know concept. How much is this energy?
What do you
So
mean
we
by
can
how much is it?
How to say? Maybe we need to put something that need this amount of energy, but we don't know
Okay.
how much is this amount of energy.
Oh, you don't know 300 joule ini berapa?
Yes, we don't know because we know concept, we know.
Actually kita ada in our laboratory kita ada satu alat, kita panggil dia calorimeter. Okay, calorimeter to measure 300 ini berapa panas ni. Let's say you light up a candle and you place your finger, you nak tahu berapa banyak heat itu. 100 joule itu berapa panas. Okay, I understand your mean. Cikgu pun selalu nak tahu itu, but tengoklah kalau kita ada chances, kita boleh cuba dekat lab. Okay, to measure what is this 300 joule, how much heat it provide, berapa panas. Okay.
Yes, berapa panas.
Okay.
Okay, thank you.
Okay, then we go to question B. Okay, in question B, they give you the rise in temperature for 750 gram of water if the electric kettle is switched for 5 minutes. Now they give you the mass of water inside 750 gram. And they also give you the specific heat capacity. So you have to count what is the rise in temperature. Okay, so now in this question, we are looking for the rise in temperature. Mean we are looking for delta theta, changes in temperature. So how to solve this? So we have determined the amount of heat required from the previous question. So we are using Q equal MC delta theta, where Q also equal to PT. Okay, so Q is 300,000. Mass, again, don't forget to convert into kg, 0.75. And this is the specific heat capacity for water. So we can find the rise in temperature. So can you tell me what is the rise in temperature here? Can you calculate? Okay, work out with your calculator and share to us what is the rise in temperature. High specific heat capacity, not easy to absorb heat. Yeah, Sinway, it absorb heat slowly. Okay, high specific heat capacity absorb heat slowly and also release heat slowly. Okay. So what is the rise in temperature here, students? So if you count, it will be 95.24 degrees Celsius. I missed the Celsius back there. Okay, 95.24 degree Celsius. Okay, this is the rise in temperature or the change in temperature. Okay, yes, 95.24, correct. Senang saja kan? You just work carefully with your calculator so you will end up with the correct answer. Okay, then we proceed to the next question. Jawapan dia sudah ada pula di bawah tu, cikgu lupa nak padam. Okay, now what do we have here? We have 200 gram of water. Okay, with the temperature of 40 degrees Celsius. So you can highlight the information. 40 degrees Celsius is mixed with another water of 800 gram boiling water. So boiling water, can you tell me what is the temperature? The second water.
100
It must,
degrees Celsius.
yeah, yes, it must be 100 degrees Celsius. So we have two types of water. Cold water of 40 degrees Celsius and a hot water of 100 degrees Celsius with the mass given for each 200 gram and 800 gram respectively. And they tell us if there is no heat loss to the surrounding, what is the final temperature when the mixture of water achieve thermal equilibrium. So we mix two kind of water. Water of 40 degrees Celsius mixed with water of 100 degrees Celsius. So what will be the final temperature of both when thermal equilibrium achieved? Okay, what formula to be applied here? Apa formula nak pakai? Okay, boys, girls. So what happened to the water of 40 degree when mixed with hot water? So the lower temperature will absorb heat, okay, while the higher temperature will release heat at the same time. So this is the concept that you must understand, okay. The cold water, the water at 40 degree will absorb heat, okay, while the boiling water at 100 will release heat. So when you count the final temperature of the mixture, it must be between 40 and 100. Okay, dia mesti ada di antara 40 and 100 degree Celsius. So heat absorbed M1 C delta theta 1. This is for the water at 40 degrees Celsius. And heat release M2 C delta T2. Okay, this is the heat release from the boiling water. So you do the substitution. Okay, so the mass of water 40 degree, pastikan you ambil mass yang betul. 200 gram in kg is 0.2. C ini 4,200, not given, right? But since they are water, so dua-dua pun ada C yang sama. Both have 4,200. So later you can cancel off this C because both are water. So this is the temperature change for the water which is initially at 40 degree. So kita label final temperature itu as T. So why T minus 40? Because the final temperature must be higher sebab dia absorb heat. So the final temperature must be higher than 40. So the temperature change T minus 40. Okay. While for the boiled water, the mass is 800 grams, so 0.8 kg. This is the specific heat capacity and temperature change. Initial temperature is 100. So once it release heat, the final temperature must be lower. So that's why the temperature change, we place 100 minus T. So we are looking for this T, the final temperature of the mixture, once thermal equilibrium is achieved. Okay, so when you solve, we cancel off C, as I said, because C is the same for 1200. So you can cancel off. So finally, you will end up with 88 degrees Celsius. So see, 88 degrees Celsius is between 40 and 100 degree Celsius. Okay, are you clear with this example? Any further question? Ada soalan nak tanya?
Yes, but not about this.
Okay. Then I think it's now 11:31. So class, I want you to try on the following question until the essay question at the back. So this is your task for today, to try all the remaining questions. So this is what we are going to discuss tomorrow. Okay, problem solving on the remaining question for structure and essay question on the SPM past year paper. Okay, so I give you some example today. So I hope you can try them back home. So tomorrow we will cast all the remaining questions in the module which I gave you earlier in the Telegram group. Okay, so anything else before we end today's session? Ada apa you nak tanya?
Teacher.
Yes.
Can we overcome this pandemic by visualize the virus?
Visualize the virus.
Maybe by visualize mean maybe we use indicator can make the virus become
appear.
appear, and we can use because it's easier for us if there's enemy is visualized and we can easy to see them. And we're using some indicator to let the virus visualize.
And then everyone has to put on the visualizer.
Maybe.
It will be a good invention, but bila you fikir ada berapa billion people in the world, kalau you nak supply a visualizer for each people, I think it will be quite impossible. Kita nak beli. First, the technology is maybe
indicator.
Yeah. So but it's a very good suggestion. Only the execution is I think a bit difficult to be conducted. So you boleh elak where you want to move from the virus. Okay. The down case is worsened. Today by day is worsened. Yesterday is 17,000. I don't know. I don't see any sign yet when the school will reopen. So as for now, we continue with this PdPR session. So I hope you can be patient. Ada yang stress ke for Akib, Baiduri, Citrin?
No.
Okay. So I hope you have anyhow any crew or by crew we have to adapt with this situation. So we have to accept whatever it is. So you just have to be prepared mentally and physically well as well. Emotional itu kena jaga. Okay, you have to care also for your emotional health, also for your physical health. Okay, so you won't face any difficulties on following this online lesson. Okay, any problem you can always discuss with the teacher. Jangan duduk diam-diam di sana. Ada problem tolong bagi tahu. Okay, we at BAGAN JAYA always open to help any of our students. So any problem, please let us know. Okay, itu saja daripada cikgu. So I meet you again tomorrow. Please try all the exercises left. So I hope you can cope with them, okay, and understand this chapter, specific heat capacity well, okay. So if nothing else, I think that's all for today. Thank you very much for your effort. Thank you very much for your time. So you can prepare for the next lesson. What will it be for Akid? What is next lesson? Baiduri, Citrin?
rejects. I don't know.
Yes, yes, in way, it is true. Okay, heat capacity, it doesn't involve the mass. Specific heat capacity, yes. Specific mean it is must be 1 kilogram for every 1 degree Celsius temperature changes. Okay, so good luck for BM, good luck for moral, good luck for maths. Okay, see you again tomorrow. Bye bye. For now, I will end this live stream now. Okay, again, thank you very much for your participation. Bye bye, everyone.